Alright, so we want to evaluate the limit of this function as x goes to 0, but we have a problem because the function is undefined at 0. So we're going to have to do a little algebra, make it look a little bit nicer. So the first thing we want to try and do is combine our numerator. So we're going to have to get a common denominator of these functions. Since our value 3 is just 3 over 1, this problem is kind of nice for us because it makes getting the common denominator simpler. So all we have to do is multiply by fancy 1, in this case x minus 1 over x minus 1, and we can go ahead and distribute and rewrite this as, I'll write that here, limit as x goes to 0 of 3 plus 3 times x minus 1 over x minus 1, all of that over 4x. So I'm off to a good start. I can do some simplification now. Get the limit as x goes to 0 of 3 plus 3x minus 3 by distributing that 3 over x minus 1 all over 4x, which I can then simplify to the limit as x goes to 0 of 3x over x minus 1, all of that over 4x. Well, the beauty of dividing by 4x, is the same as multiplying by the reciprocal. So I can rewrite this as limit as x goes to 0, 3x over x minus 1 times 1 over 4x. And now you can see I'm going to get a little bit of cancellation here because I have x over x. So I get the limit as x goes to 0 of 3 over, and now here I have to distribute that 4 in, so I get over 4x minus 4. Now I can finally evaluate this function as x goes to 0. I just substitute 0 in for x. I get 3 over 4 times 0 minus 4. Well, 4 times 0 is 0, so I get 3 over negative 4, which I'm going to write like that. Negative 3/4 is our limit.